he has given a single phase auto transformer with different taps, and also if you see the secondary of auto transformer, it is feeding different loads at different tapping points. What is the current flowing through the section BC of the auto transformer? So he is asking the current in this section. So I can put like this, because I am sure, because the current is less here, the current is more here. That means some current has to feed. Primary side you are having more number of turns, so less current will be here. And if you see the secondary side, less number of turns are there. That means more current will flow here. So that means definitely the current will be in this direction. We will see which direction it is. Okay. So first I will see the current in section CA due to load 400 ohms. So that means now I am considering only this is the primary and this is secondary. That means this is not there. I am trying to calculate separately. So if you see this 400 volts, it was connected between 100% and 25%. So how much this will be? This will be the 75% of the turns. So what is the voltage? The voltage VAC is equal to 0.75 times 400. Okay? So this is nothing but 300 volts. That means the voltage across this load is 300 volts. So if it is 300 volts, what about the current? The load current is equal to 300 volts by 400 ohms. So this is equal to 0.75 amperes. Now I want to find out the corresponding input current. So the corresponding input current means it's like N1 I1 equal to N2 into I2. So here N1 I1 is equal to N2 into load current. Or you can also write this as a V1 I1 is equal to V2 into I load current. So I want I1 equal to, so V2 is 300, the load current is 0.75 by the supply voltage is 400. So this value, if you simplify this, you will get 0.5625 amperes. So this is the input current from the supply. Now what about the current through CA? The current through CA is nothing but the load current minus the input current. So the load current is 0.75 minus this is 0.5625. So this is equal to 0.1875 amperes. So if you see the direction of current, this is flowing from the terminal C to A. Okay. Now I have to find out the same procedure. I have to find out the current due to the load 200 ohms. So 200 ohms. So if you see here, this 200 ohms is connected with 75% and 0. That means the number of turns are 75 turns. So the voltage is nothing but 0.75 times 400. So that means this is also 300 volts. So now the current in section BD due to load of 200 volts. So So VBD equal to 0.75 times 400, so this is 300 volts, and the load current equal to 300 volts by 200 ohms, so this is 1.5 amperes. And out of the corresponding input current, so 400 into I1 is equal to 300 into 1.5. This implies I1 equal to 300 into 1.5 by 400. So this is 1.125 amperes. What about the current in the section BD is equal to 1.125 minus, I have to put the first load current here. So 1.5 minus 1.125. So this is equal to 0.375. So this is also the direction is from down to up. So that means the current direction is from here, from D to B. So here, because of this load, so now the current in the section is equal to the sum of these two currents. So that is the current through section CA and the section through. So this is the current through section BC. So this is equal to 0.375 plus 0.187. So this is equal to 0.5625 amperes.